Hello guys, so this will be a video on arithmetic subarrays lead code problem 1630. So before I start with this video, let me explain in short on what this question is asking you. So your objective is to get the output as a vector of Boolean values, which is true, false, true, and something like this. So as you can see from example 465937. So this was the part where I was confused on previously, but now I'm pretty much clear. When it says L equals 0, 0, 2, this L represents the left pointer, whereas R represents the right pointer. When you have your first element 0 in your left pointer, uh, and for your right pointer, you'll have your first element to be 2, which means you'll have 0 to 2. So whatever, so 0 to 2 will be the window actually. So when it's 0 to 2, you'll get 0 as 4, 6, 5. And when it's from 2 to 5, this means that your left pointer is at 2, index number 2, which is 0, 1, 2, which is 5. And your right pointer is at 5, so 0, 1, 2, 3, 4, 5. So it'll start from 5 to 7. Um, Now, first, let me write the code, and maybe from that way, you'll be able to understand it in a pretty clear way. Now, what is the output that we need? Let's say, um, let's put that output as a result, okay? And we need to return that result, the return result. And since this result is a vector of Boolean values, so this is how you initialize a vector named result. Now, let's run a loop. Main I 0 I is less than size of L. So it depends on what size you have for your L. We will iterate throughout those values. Um, Sorry, I think so. That's the L. Or is it L size? Yep, L size I plus plus. Now, whatever values that we iterate, need to we will need to um, put those values in a temporary array. Say mm, vector in type temp. Okay, now run another loop for int I equals to whatever the values that we have in the left pointer. uh, for the first, we'll initialize with that. For I int I equals to li, and let's say this to be j, so that we don't want to confuse ourselves with the initialization that we did in the uppermost loop. mm, J is less than or equals to R of I. Now, why did I choose less than or equals to? So that whatever values that we have in right pointer first column, we'll have to include that as well. So that's the reason behind this being less than and equal to. And let's run it. Let's have this increment by 1. Now, for each increment, we will put the values in temp. So uh, temp to push back push back what values do we want to push? Whatever values that is in the nums, which means 465937. Okay, and now after that we will um, have all the answers pushed to result dot push back on arithmetic progression. That would be a function which we'll define in a bit. So now we've done everything for the main code. Now let's define this function find AP. So how do you do that? Since this function it takes an a integer data type as integer, we will have integer find AP, and it will take a vector of temp sorry, integer values, um, and then oh sorry, this should be bool because this will return a boolean value, and it will have, let's say, temp. So let's see if the if so if we have only one element in an array, we can consider the arithmetic sequence to be one, and even if the sequence even if the array has two elements, we will still consider that to be an arithmetic sequence. So if temp dot temp dot size is less than or equals to 2, return true. True. And then let's sort uh, the elements from temp, because uh, the reason behind being that whatever value we get here, we will uh, just rearrange it in any way so that we can see if any combination can have the same difference that we need to find the arithmetic sequence. Okay, temp dot end, and now int diff equals to temp 1 minus temp 0. Now, since we need to have equal difference in all the elements, mm, and we initialize that with the second element minus first element. Now, what you do is you run a loop where int I equals 1, I is less than um, in the size I plus, and see if temp I minus, minus temp I minus 1 equals to def is if the difference does not equal um, doesn't equal the initial difference, then we simply return false, and in other case it would just simply return true. Let's see if this code runs nicely. Come on. Yes, as you can see, the code worked nicely. So um, yes, this is it. Mm. Now, to see where this code can be actually implemented, you can see that I've already done. Let's say these are the speed of your vehicle. Let's say in certain time frame from 80, 85, 75, 60. As you can see, there is a slight increase in the speed from 80 to 85, which could represent that the traffic congestion was lessened in this window. However, if you were to select a window from 85, 85 all the way to the end, you could see a gradual decrease, especially from 85 to 60, 40. You can see a rapid decline in the speed, which means that all of a sudden the traffic congestion increased, and from 48 to 32, there had there has been a gradual decrease in the speed, so which could represent that the traffic has slowed down. However, if in the case of Parvati, her speed is just varies, so this would just give us false almost all the time, which could mean that there is some anomaly, there are some errors or some conditions which makes her speed fluctuate in, you know, up and down. So yes, and that is how this code could be implemented.